Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2. We are going to make a presentation about foundation. Okay, now I'm going to introduce our company, which is Smartland Consultant. Corporate profile. Premium firm specializing in geotechnical site investigation, soil structure analysis, and code compliance foundation design. Organization structure. Putri Nurdina is our project manager and lead engineer. Siti Sholiha is geotechnical engineer. Structure engineer Nur Atika Izati. CAD drawing and modeling special is Ainu Mardia, and Fatina Hazika is QA and QC coordinator. Project mandate: deliver safer, optimized and sustainable structure solution adhering strictly to Eurocode 7 and BS1377 standard.
For Sector 1, Overview and Objective. Design Site Lot 392 GM 1138 Mukim Peserai Batu Pahat Cumi. For superstructure, 3 units of single-story terrace house. Site analysis: interpret site-specific borehole log to establish reliable geotechnical design profile. For strategic justification, evaluate and technically select the optimal foundation type, shallow versus deep.
This slide shows the summary of subsurface soil profile from 4 boreholes, which is borehole 1, 2, 3 and 4. The purpose of this table is to understand the ground condition at the site, including groundwater level, borehole depth and general soil particles. All boreholes are referred to the same radius level, which is 0 meters. The groundwater level was found between 4.5 meters and 6 meters below ground level. This is important because groundwater can affect excavation work, especially if the excavation depth is below the water table. Therefore, dewatering or proper excavation support may be needed during construction. For borehole 1, the borehole is the deepest at 36.3 meters. The soil consists of topsoil and medium dense silty sand, followed by very dense sand or silt with SPT value more than 15. For borehole 2, the borehole depth is 0.25 meters, and this indicates that the soil strength increased with depth. For borehole 3, the borehole ends at 27.18 meters. The soil consists of medium stiff sandy silt and silty sand underlain by very dense silt. And lastly, for borehole 4, the soil consists of alternating loose silt and sand layers before reaching dense gravel strata. This means the upper layer may be weaker, but deeper layer is more competent and overstable. However, the presence of groundwater and loose upper layer must be considered during foundation and excavation works. The main purpose of this method is to identify the soil condition, soil strength and groundwater level at the site before deciding the suitable foundation system. The first method is boring operation. Rotary boring rings were used to drill the boreholes, while steel casing and bentonite slurry were applied to prevent the borehole wall from collapsing during drilling. The second method is SPT exploration or standard penetration test. This test was carried out at 1.5 meter interval using a 63.64 kg hammer. The SPT result helps to determine the relative density and strength of the soil. A higher SPT value indicates denser and stronger soil. The third method is hydrology and probing. This involves identifying the groundwater table and carrying out Macintosh probe test to check the stiffness of the upper soil layer. Overall, these field tests are important because they provide the required soil data for excavation planning, groundwater control, and foundation design.
Hi, my name is Putri Nordina binti Muhammad Zaudin and my matric number is CF230212. Okay, I will explain the structural demand of the proposed building, which is based on the structural analysis. The maximum design load transfer from the superstructure to the foundation is 355 kN. To simplify footing design process, the column load were divided into 3 groups, which is group 1 consists a load between 50 and 99 kilonewton with a maximum load of 99.8 kilonewton. It's covering 18 column location. And then group 2, load between 100 and 199 kilonewton with a maximum load of 199.5 kilonewton. It's covering 19 column foundation. Group 3 is consists load between 200 and 399 kilonewton with a maximum load of 355 kilonewton. It's also covering 70 column location. So this grouping helps standardize the footing design and make the design process more efficient. Okay, next I will explain for the design verification. After determining the structural load, foundation design was verified using bearing capacity and also settlement analysis. For the bearing capacity check, allowable load calculated using the Terzaghi method is approximately 9,396 kilonewton. Meanwhile, the allowable load calculated using the Meyerhof method is approximately 13,444 kilonewton. Okay, both values are significantly higher than the maximum design load of 355 kilonewton. So they show that the soil has sufficient bearing capacity and is able to safely support the proposed structure. For settlement verification, the estimate settlement is 7.52 millimeter, which is below the allowable limit of 25 millimeter. Therefore, the settlement is considered safe and meets the serviceability requirement. Based on both bearing capacity and settlement checks, the proposed foundation design is safe and suitable for construction. Thank you.
For discussion, I will talk about geotechnical evaluation. First, between capacity and demand, both methods yield safe allowable structural load. The selected footing show extremely low utilization ratios, completely eliminating plastic shear failure risk. Next, in terms of soft soil treatment, coastal alluvial deposit post-settlement risk, dynamic compaction or vibroflotation densifies soil, while PVD and preloading accelerate consolidation. Then groundwater control. A shallow groundwater table requires active dewatering and temporary sheet piles, while high sulfate presence dictates concrete with low water cement ratio. To conclude this project, the geotechnical and structural design successfully confirmed that the proposed foundation system is fully competent to support the superstructure demands. Analytical evaluation verify absolute safety against shear failure and settlement limits under load. To prevent excessive long-term consolidation and settlement in the alluvial strata, localized ground treatments such as dynamic compaction, prefabricated vertical drains, and surcharge preloading are highly recommended. Furthermore, standardizing the footing size across all lines offers an outstanding opportunity for value engineering, downscaling the dimensions for lighter column loads while optimize materials and reduce excavation costs without compromising safety. Thank you.